Okay, welcome back. So hopefully the first thing you did is the only thing you can do with this triangle right now is use cosine law to solve for the third side. So if you set up your cosine law equation, it should look something like this. And I got x being approximately 14.92. And this is from here where you have to be careful. So right from here now, you've solved for x. There's two angles left to solve for. Now you have all three sides. You could use cosine law to solve for an angle. And if you did that, there'd be no problems at all because your calculator will always give you the right answer. However, I'm betting most of you use sine law because it takes less time. Now you have to be a little bit careful here because depending what angle you solve for first, you could get an error based on from your calculator. Because the problem with this calculator, with this triangle, is that there's an obtuse angle in it, and you can't tell based on the diagram. We didn't know based on when you drew the diagram, but if you happen to set up the sine law to solve for theta first, so if you were going to do so, you'd have had sine theta over 17 and sine of 61 degrees over 14.92. Okay, if you were to do that, your calculator would spit out an answer of 85.24 degrees. And you wouldn't think anything of it, and you just go on happily on your merry way and solve for alpha using the sum of the angles in a triangle. So 180 minus 61 minus 85.24 would be 33.76. Okay, and you think your answer was correct, but then you have to take a look here and say, okay, well, this actually doesn't make any sense. And at first thought, it might seem like it makes sense. I mean, looking at what I have labeled here as the wrong answer, you have your largest angle across from your largest side, your smallest angle across from your smallest side, and so on and so forth. So it seems correct. However, if you check the sine law ratio between the last two angles that you saw and the sides across from them, it actually isn't true. Okay, and this wouldn't be necessarily something that you'd think to check. So you might go on about your merry way again, thinking your answer is right. However, the problem is your calculator does not know that theta is actually an obtuse angle. Okay, it assumes it's an acute triangle. It doesn't know any better, so it's automatically going to give you the 85.24. That's actually not going to be the case. So the way we can get around that, and we touched on it in the last lesson on sine law and cosine law, is you always want to make sure you solve for the smallest angle first if you ever have the choice. Okay, because we know the smallest angle in a triangle is going to be acute. So if your calculator gives you an acute angle when you solve for it, you don't have to question. You don't have to worry about it. Oh, is it maybe obtuse? Is it maybe not? If it's the smallest angle in a triangle, it has to be acute. You can't have more than one obtuse angle in a triangle. So what you need to solve for first here, instead of for theta, you need to solve for alpha first. And how do you know that's the smallest angle at what's left? Well, it's across from the smallest side in the triangle. So you have to solve for alpha first using sine law. That gives you 24.23 degrees. And then you can use your sum of the angles in a triangle to get your third angle. Okay, so again, it's new this year because we never had to deal with obtuse triangles back in grade 10. But always solve for the smallest angle first. Okay, it's not an option. Okay, so with that in mind, there's no ambiguous case of the sine law here. It's just potential issue with our calculator giving us the wrong answer. Let's take a look at one down here and see if this is going to lead to an ambiguous case. So I'm given two sides and an angle, so I'm going to sketch it out. So I have 52 degrees here for my angle M. The side across is 43. And my other known side is 48. So you'll notice here I have two sides and an angle. It's not the contained angle between the two sides that's given, so this is a sine law problem, and I would have to use sine law to solve for an angle. This is where I could potentially have an ambiguous case. So what am I going to do? I'm going to calculate the height first. That's how I check to see if it's ambiguous. So it's going to be 48 times the sine of 52 degrees. Okay, so that's going to give me 37.8 approximately for the height. So with that in mind, let's see how many triangles we have. So we know we have at least one triangle. It's possible to create a triangle because this 43 is longer than the height. So let's see what happens if I try to swing this side over. Because it's smaller than 48, and it's going to touch somewhere over here before I exit the triangle and create a second triangle over here, also with that length of 43. So there are going to be two possible triangles out of this. This is the ambiguous case. So I'm just going to draw these triangles separately here so we can see them. So the first one's going to be my original green one here. So I'm going to have, sorry, let's draw that a little bit better. MDR, with this being 52 degrees, 48 and 43. So that's one triangle. And my other one here I'm going to draw in blue. It's going to be an obtuse triangle. So that's going to be 52 degrees in there. That's going to be your side R. Or sorry, your angle R. And that's going to be your 48. So two possible triangles. So now we know there's two triangles, we actually have to solve them both. Okay, so you might think, okay, now I have to solve two triangles, how do I go about this? It's actually not too bad. Remember, the only thing we can solve for right now is the angle across from the other known side, which is angle R in this case. So I'm going to solve for that first, using the only way I know how, which is sine law. So it's going to start off just like normal. So I'm going to have the sine of 52 degrees over 43. That's going to be equal to the sine of R, which I don't know, all over 48. Okay, so I'm going to run that through my calculator and solve for R. And the angle that my calculator is going to give me is 61.6 degrees. Now, again, we know the calculator is going to give you an acute angle. So what this is giving you is the angle inside this triangle right here. But we know, we're smarter than our calculators, we know that there's two possible triangles. So while we know the calculator is giving us the one in this acute triangle right here, we need to find the related angle in the obtuse triangle. So to get that, we just take the angle that we're given, and we subtract it from 180 degrees. Okay, and that gives me a second possible angle of 118.4. Okay, so two possible triangles, one with an obtuse angle of 118.4 and one with an acute angle of 61.6. Okay, so this is where now my problem kind of splits off. So again, just to recap here, my calculator gave me one answer. I had to find the other answer on my own, knowing there's a second triangle by doing 180 minus that angle, 61.6. So from here it kind of branches off, and I have two different problems to solve. I have to solve the acute triangle, the one where R is 61.6, and the obtuse triangle where R is 118.4. So in each case we have to solve for angle D. So I'm just going to do it one at a time. So for my first triangle, angle D is going to be 180 degrees minus 61.6 minus 52 degrees, which gives me 66.4. Okay, I'll label that in here. Okay, and with my second triangle, I'm just going to keep these separate here, I can still find D the exact same way, except now I just have a different angle R to work with. So in this case, angle D will be 180 degrees minus my 52 degrees that I had at angle M, but minus my 118.4. And again, run that through my calculator. I should get 9.6. So again, two possible triangles means two possible values for that third angle as well. Okay, so last but not least, the only thing that's missing now is that third and final side. So how do we find that third and final side? Well, we're going to use sine law again, and again we just do it twice. Once for the acute triangle, where angle D was 66.4 degrees, and one for the obtuse triangle, where angle D was 9.6 degrees. So I'll set up both equations. I'll let you work through the math on your own. But to finish this one up here, if we want to solve for side D in each case, will be the sine of 66.4 degrees over D. And again, you have both other ratios. I'd recommend using the given ones. They haven't been rounded at all. So we're going to use sine of 52 degrees over 43. Okay, we're going to solve that equation for D. And we're going to do the same thing over here with the obtuse triangle, except now it's going to be sine of 9.6 degrees over D, and again sine of 52 degrees over 43. Okay, so take a second, solve each of these. Okay, and you get yourself two possible answers. So once you figure out that the triangle is ambiguous, and you solve for the angle and find the related obtuse angle to create your two separate triangles, it's really just everything else you've done before. You're just doing it to solve both triangles. So it's a little bit more work, but nothing we can't handle. Okay, and again, normally I'm not going to tell you if it's ambiguous or not. That'd be something you'd be responsible for finding out on your own, again, by calculating the height and comparing it to the other known sides. Okay, so a couple others to finish off here. So let's take a look at this triangle. Now, one thing I want to ask you for this, once you take a look at the dimensions here, is what's wrong with this triangle? Okay, is there a reason why we have an issue with it? And hopefully you recognize here that the issue is with the fact that the 115-degree angle is across from the side length of 15. Now the problem with that is we have a side length that's larger, which is 25. That would mean the angle across from the 25 would have to be larger than 115. If we have an angle larger than 115 as well in this triangle, if you add up all the angles together, that's going to be much, much more than 180 degrees. So this triangle here is actually impossible because it's not possible for this 115 degrees to be across from anything but the largest side in the triangle. Okay, so once we figure out this triangle is impossible, there's nothing else we can do. Okay, last one. So what I'd like you to do is first set this one up on your own. See what kind of situation you have. See if it could potentially be ambiguous. So find out by calculating the height and comparing it to the other sides. If it is ambiguous, solve for both triangles. If it's not ambiguous, just solve for the one triangle. So give that a try on your own and push play and you're ready to see the answer together. Okay, so take a minute and check your answer here. I calculated the height to be 41.9. The triangle does exist because, again, this 48 is longer than the height. But if I try to create a second triangle and I bring this 48 over, because it's longer than the other side of 47, it's not going to create another triangle inside over here. It's going to create something out here which can't exist. So this is only one triangle possible. Once we find out it's only one triangle, then we're happy actually, because it becomes just like a grade 10 problem. So we can first solve the only thing we can, which is angle W, the one across from the side of 47. So I use sine law for that. Sum of the angles in a triangle to get my third angle, and then sine law finally again to find my last side. So that's it, that's all. I know it's a little bit tricky to get your head around, and sometimes there's actually some word problems that can create ambiguous situations as well based on the information given. So please make sure you practice so it becomes a little bit easier for you to visualize. And after this we'll move into some 3D problems. Okay, that's it.